Hello, this is Amit Kumar Yadav presenting a video on radio wave propagation. Let's talk about radio waves. Radio waves are the part of the electromagnetic radiation family. The path traveled by the radio waves between a transmitter and a receiver may be complicated. The waves may reach the receiving point by propagating along the straight line, bending around the curved surface of the earth, or being reflected back from the ionosphere. The manner in which radio wave propagate depend on number of factors such as wavelength and the intensity of the sun's illumination of the earth atmosphere. This block diagram shows the transmission of the signal from radio transmitter to radio receiver. Based on the propagation path, mode of propagation are defined as direct mode, ground wave propagation, tropospheric wave propagation, and ionospheric wave propagation. Direct mode of propagation. In homogeneous media, radio waves propagate rectilinearly at a constant speed. The line of sight of propagation radio waves between transmitting and receiving antennas. This method is also used in cordless phones, cell phones, walkie-talkies, and all other wireless devices. This diagram shows the transmission of signal from transmitter to receiver by direct mode of propagation. Ground wave propagation. In this mode of propagation, the wave propagates along the ground. It is utilized for short range of communication. The degree of attenuation is very much dependent on variety of factors like frequency and distance. As the frequency increases, loss may also rise. As the distance increases, the magnitude of propagation signal decreases by a large amount due to attenuation by Earth. This mode used for low frequency operations, which is up to 2 MHz. This diagram shows the propagation of signal from transmitting antenna to receiver antenna in circular curved waveform. Tropospheric wave propagation. Radio wave propagate along the Earth's surface through the troposphere. It is found that the average value of the refractive index falls by about 0.004 for every kilometer increase in height. As the wave speed of the propagation is higher in the upper layer of the troposphere than in lower layers, the upper part of the wave front overtakes the lower part and the wave front is tilted. This is the beam is bent. This phenomena is called normal tropospheric refraction. It permits the propagation of radio waves beyond the limit of line of sight propagation because the refraction allows the waves to bend around the curvature of the earth. This diagram shows the bending of the radio wave signals around the visual horizon, which is called tropospheric bending. Ionospheric propagation. When we use high frequency wave for propagation by ionosphere, the radio signals leave the transmitter on the earth's surface and travel toward the ionosphere, where some of these return back to the earth and some of them are lost in unknown space. If they are returned to the earth, then ionosphere may be viewed as vast reflecting surface enclosing the earth that enables signal to travel over larger distances. The electrical properties of the ionosphere are different for different frequency ranges. This diagram shows the loss of radio waves in unknown space and also shows the reflection of radio waves which can be received by the receiver. Losses in propagation. The signal path losses is the reduction of power density of electromagnetic wave or signal as it propagates through the environment. This affects all the communication systems. There are many reasons for the radio path losses that may occur. Diffraction losses, multipath losses, absorption losses, terrain and atmosphere losses, free space path loss, and etc. Radio and antenna engineer uses following simplified formula for signal path losses between the feed point of two isotropic antennas in free space. Path loss is measured in decibels. L is the loss, D is the distance, and L lambda is the wavelength. This summary diagram concludes all the important points of this video presentation. As this shown, there is ionosphere which reflect back the radio signal. The troposphere curves the signals towards the other receiving point. there is the direct mode of communication between two points and the ground wave mode of communication. Thank you for watching the video.